Hello and welcome to Lab 2, VTP Servers and Clients. For those of you using the Cisco Pressbooks, note that the material covered in this video is also covered in the IC&D 2 books, Chapter 1. This lab has three main objectives. By the end of this lab, you should be better able to configure VTP on Cisco switches, in particular VTP server and client modes. You should be better able to verify that switches meet the required conditions in order for VTP to work. And you'll also see how to verify that a VTP client has learned VLAN information from a server. This lab uses three scenario steps to reach these objectives. In the first step, you'll see how to configure one switch as a VTP server and another switch as a VTP client. In the second step, we'll review and complete all the VTP requirements so that the two switches can indeed exchange VLAN configuration information. Finally, in the third step, we'll actually configure a new VLAN on the VTP server and confirm that the VTP client has indeed learned about this new VLAN. So let's begin scenario step 1 by examining the network topology that will be seen in this particular video. We've got a switch named SW1 or switch 1 that has a single host connected to it, and this switch will be the VTP server. Now, to configure the VTP server, we've got some simple things to do. First of all, VTP defaults to be in server mode, so we don't need to explicitly configure the mode to server mode. However, we do need to configure a domain name. VTP doesn't work unless the switches have a domain name configured, and the domain name must match. And because it's a good idea in real life, we'll configure a VTP password, in this case a value of Barney. Switch 2 will also be in this network, and of course it will be a VTP client. Now, unlike the VTP server, we will need to configure the VTP mode, of course, because switches default to be in server mode, so we'll start by enabling VTP client mode on switch 2. Then, just like we did on switch 1, we'll assign a domain name of Fred and a password of Barney. Now, if you're observant, you'll notice that Fred is lowercase on switch 2. That's on purpose. It won't work that way, but I'm going to misconfigure the domain names between the two switches just so you can see what the show commands look like, and then I'll come back and fix that. Finally, for this scenario step, the two switches will be connected by an Ethernet link. However, this link will be configured as an access link for scenario step 1. In other words, there won't be any trunking going on in that link. Also, for easier cross-reference with some of the output of the show commands that you'll see here in just a minute, I've included the IP address of each switch in the figure. So let's take a look at the command line interface for a moment. Before I did the commands you're about to see, I erased the vlan.dat file from Flash, erased the configuration, reloaded the switches, and then just added a few administrative things unrelated to VLANs and VTP. So these two switches are in a state that's as pristine as possible in regards to VLANs and VTP. So if we do a show VTP status command here on switch 1, there are a couple of important things to note. First of all, note that it's in server mode, which is default. Also see that there is a null domain name. In other words, there's no domain name set, so this server will not communicate with VTP with any other VTP switches at this point. Also note the revision number is 0, and we'll watch that revision number change over time throughout this lab. And also note the value of the MD5 hash calculated by this switch. In order for two switches to use VTP to communicate, both switches must have calculated the same MD5 hash value. So next, let's go to switch 1 and configure VTP. Now we just saw that switch 1's already in VTP server mode, so if we get into configuration mode, and simply type the VTP domain Fred command, that sets the VTP domain name to Fred. Then if we give it the VTP password Barney command, that sets the password to Barney. Now if we get out of configuration mode and then do another show VTP status command, we see some interesting information. In particular, note that the revision number is still 0 because we actually haven't configured any VLANs yet. We've just configured a few VTP settings. Additionally, note that the MD5 hash has changed as compared with the last time you looked at it, because the MD5 hash is based on both the domain name and the VTP password. Additionally, note the domain name that we set to Fred is indeed showing up there as Fred. Next, let's switch over to switch 2, and we'll basically do the same thing. Get into configuration mode, but now instead of defaulting to VTP server mode, we'll type in the VTP mode client command, which sets the mode, of course, to client mode. And then the same commands we saw on the server switch. VTP domain Fred and VTP password Barney. Now let's go ahead and get out of configuration mode here and repeat the show VTP status command. Now one of the first things you'll note there, if you focus on the MD5 hash value and compare that to what you saw just a few minutes ago back on switch 1, is that the values are different. Now you probably noticed that I typed a domain name of lowercase f Fred here on switch 2, whereas I use an uppercase F on switch 1. So it turns out the MD5 hash is based on both the domain name and the password, so the fact that they're different between the two switches means there's a different hash. Once the two switches do send VTP messages to each other, they'll decide not to exchange VLAN information because their hashes are different. So to fix that, let's go back into configuration mode here on switch 2 and type in the VTP domain uppercase F Fred command so that now the two values match. Once again exiting configuration mode, the show VTP status command now shows a different MD5 hash value than we saw formerly on switch 2. But if we switch back over to switch 1 briefly and do show VTP status, note that the two MD5 hash values now do indeed match between the two switches. So now we know that we've got the correct domain names and passwords with the correct upper and lower case configured so that the two switches could exchange VTP information. So at this point we've configured VTP on both switches. However, before we wrap up this step, let's take a look at the status of our trunks. If we do a show interface trunk command here on switch 1, we see that there are no lines of output. Now that means that there are no active trunks or no operational trunks right now. Then if we do a show interfaces gigabit 0/1, remembering from the diagram of the network that switch 1's gigabit 0/1 interface is the link that's connected to switch 2, note that indeed the interface is up and up. So the interface is physically working, it's just not a trunk. One last thing that's interesting to note, if you do a show VLAN brief command again on switch 1, and you look over to the far right for VLAN 1, note that it says that gigabit 0/1 is one of the interfaces that is assigned to VLAN 1. So this is confirmation that not only is gigabit 0/1 up, but it's also assigned as an access interface in VLAN 1 right now. Next, let's move on to scenario step 2 and examine the trunking requirements between the two switches. Now in the previous step we examined the domain name and password, noting that if the MD5 hash values are the same on both switches, that we know both those two values match. Now that's a requirement for two switches to exchange VTP information. The third requirement is that there be a working trunk between the switches. Now as we just noted, the link between switch 1 and switch 2 is currently an access link in VLAN 1. So in order for VTP to work, the switches will only send the messages on trunks, so we need to configure the link that's between the switches as a trunk. As it turns out for this lab, I used two 2960 switches, both of which default to a trunking setting of dynamic auto. That means they're both willing to negotiate trunking, but they require that the switch on the other end of the link start the negotiation. So they're both sitting there willing and ready, but neither wants to start. So if we get into configuration mode again, and get into interface gigabit 0/1 interface configuration mode here on switch 1, then we just need to say manually enable trunking with the switch port mode trunk command. Now by doing so, it makes switch 1 start the negotiation process as well. So if we get out of configuration mode and do the show interfaces trunk command here on switch 1, notice now that gigabit 0/1 is indeed listed as a trunking interface. So we now meet the third requirement that a trunk is formed between the two switches. Another point of interest is to look at the output of the show VLAN brief command. You might recall that this command listed switch 1's gigabit 0/1 off of VLAN 1 as an access interface. If you examine the far right of the output now, notice that gigabit 0/1 is not listed in this output. Trunk interfaces are not listed in the output of the show VLAN brief command because trunks are not assigned to a single VLAN. At this point, both switches are ready, willing, and able to use VTP to exchange VLAN information. However, if we look at the show VTP status command starting here on switch 1, note that nothing's really changed at this point by virtue of having the trunk come up. We've still got a revision number 0 That's because there have been no VLANs configured yet. We still have the MD5 hash value, which happens to match switch 2. In fact, if we switch over to switch 2 briefly and do the show VTP status command, note there the MD5 hash does indeed match the value on switch 1, same domain name, and still revision number 0. So now we're primed and ready to configure VLANs on switch 1, so we'll do that here at scenario step 3. So now that we've finally gotten VTP and trunking configured so that VTP will work, step 3 focuses on the actual configuration of a VLAN. So we'll start out there on switch 1, which is the server, and create VLAN 2 using the VLAN 2 command. Now once that's done, switch 1 will update its VTP revision number by adding 1. It was 0, so we'll add 1. So of course the new revision number will be 1. Then switch 1 will send VTP messages to switch 2 describing the new VLAN database. Switch 2 will say, oh, we match up on our domain name and password. It's a 1 bigger revision number, so let me use this new VLAN database. So now switch 2 will know about VLAN 2, and its VTP revision number will be 1. At that point, both switches know about VLAN 2, so we can do the traditional configuration of assigning different ports to VLAN 2, and as you might guess, the 2 hosts shown in this picture will be added to VLAN 2. So we'll start out with step 3 by configuring VLAN 2 on the VTP server, which of course is switch 1. So if we get into configuration mode, and then simply type the VLAN 2 command, that creates the VLAN. Note that the command prompt has changed to where we're now in VLAN 2 configuration mode as well, so you could do one of several commands. In particular, we'll try the name Wilma command just to give this VLAN a name that might be a bit more memorable to us. So that's all there is to it. So let's take a look at what happened here on switch 1. If we do a show VLAN brief command now, if you look down to the highlighted portion, note that VLAN 2 does indeed show up with name Wilma. If you look further to the right, notice there are no interfaces listed. While VLAN 2 exists, we haven't assigned any access interfaces to VLAN 2 yet, so there are none listed there on the far right. Next, if we do a show VTP status command, and focus on the revision number, note that the revision number, just as described in the graphic a few moments ago, indeed now shows a revision number of 1. Finally, if we do a show interfaces trunk command, notice that gigabit 0/1 is still a trunk, but if we look down to the very last stanza, notice the highlighted portion lists the fact that VLAN 2 is a VLAN whose traffic will be forwarded across this trunk. If VLAN 2 were not listed down at the bottom, there's some reason for which this switch would not forward traffic in VLAN 2. For instance, maybe Spanning Tree had decided to block on this trunk. In this small network, of course, this trunk would never block for any VLAN because there's no redundancy. The more interesting activity happens over at switch 2, the VTP client. So if we switch over to switch 2 and do a show VLAN brief command, notice that now VLAN 2 Wilma does indeed show up on switch 2, meaning that switch 2 dynamically learned about VLAN 2 from switch 1. As another confirmation of that, if we do a show VTP status command, note that the revision number, which was formerly 0, has now been updated to a value of 1. Additionally, note the last updater that's listed toward the bottom of the output. It lists switch 1's IP address of 192.168.1.1, meaning that switch 2 most recently learned its latest VLAN database from switch 1. So far I've shown you how to create the VLAN on the VTP server and have the VTP client then dynamically learn about that VLAN. However, on both switches you need to add the appropriate interfaces as access interfaces into that VLAN. So continuing on switch 2, let's get into configuration mode and then configure interface fast Ethernet 0/2 to be an access interface in VLAN 2. So switch port, access, VLAN 2, and press enter, and get out of configuration mode. Well, let's see what happened. If we do a show VLAN brief command, notice in the highlighted VLAN there, VLAN 2, on the far right now, there is indeed a single interface listed now, whereas there were no interfaces before, and that interface, of course, is fast Ethernet 0/2. To complete this configuration, we need to go back to switch 1 then and get into configuration mode as you see here to add interface FA01 into VLAN 2. So we'll use a switch port, access, VLAN 2 command in interface FA01 configuration mode. So that completes the configuration requirements. If we get out of configuration mode just to confirm things, we do a show VLAN brief command, and there it is on the far right. We see the fact that FA01 on switch 1 is now assigned to VLAN 2. Finally, both hosts are in the same VLAN, VLAN 2, and now they can successfully ping each other. This concludes IC&D2 Lab 2. In this lab, you've learned how to better configure VTP on Cisco switches. You learned how to verify that the required conditions are met that allow VTP switches to communicate. And you've seen how to verify that a VTP client has learned VLAN information from a VTP server.